Hello everyone, welcome to your 11-2 lesson on comparing data sets. Our learning target for this lesson, we are going to be able to use measures of center and spread to compare data sets. We will use measures of center to interpret and compare data sets displayed in dot plots, box plots, and histograms, and we'll use measures of variability such as the MAD and IQR to interpret and compare data sets. All right, so in our vocabulary, why don't we go ahead and define what the MAD is? That stands for mean absolute deviation. We can call it the MAD or MAD. Really, you can say it however you want. Or you can say mean absolute deviation. All right, so the mean absolute deviation, or MAD, the MAD of a data set, is the average distance between each data point and the mean. So in general, on average, how far away are all your data points from the mean? It kind of gives you a good idea of how accurate the mean is. When you have a smaller mean absolute deviation, that means there's less spread of your data, that your mean is more reliable. It's a more accurate representation. If your MAD value is larger, that means that your data values on average are further away from the mean, which means you have a larger spread of data. And maybe the mean is less reliable as a representation of the data. So let's just kind of summarize that. It gives us an idea about the variability in a data set. And kind of gives you an idea of how spread out the values are. So when we say the variability, that's kind of what we're talking about. All right, good thing we put a big box to fill in there for that definition, huh? All right, interquartile range, IQR. So let's just make a note that this is going to be a value we can use when we're working with box plots specifically. So the interquartile range, the IQR, describes the middle 50% of the values in a data set. And let's just put in parentheses, when in order. So we know if we're doing a box plot, we are ordering the numbers first before we find the minimum, maximum, median, quartile 1, and quartile 3. So to calculate the IQR, what we do is we take our Q3, which is the median of the upper half of your data, and we subtract Q1, which is the median of the lower half of your data. Just a reminder what that looks like. If you have a box plot, here's just an example. That Q1 and Q3, Q1 is this value right here, kind of the left side of your box. Q3 is going to be over here on the right side of your box. So you're kind of looking for what is the range of the box of your box plot. This is the middle 50% of your data. So your IQR is essentially, you know, Q3 minus Q1, the range of that box. And just a little reminder, box plots take your data, The median right here divides it in half. So here's the lower 50% of your data. Here's the larger 50% of the data, or the upper 50%, I should say. We can see it's a little bit more spread out over here in the upper numbers, and it does divide it into quarters. So here's 25% of the data, 25% of the data, 25% of the data, and 25% of the data. So to go from Q1 to Q3 is the middle 50% of the data when it's in order.